James Webb Space Telescope, the largest and most expensive instrument ever flown. 100 times more powerful than the 31-year-old Hubble telescope, Webb can see back in time all the way to the let there be light moment. That instant when a cold, dark universe ignited into stars.
This space telescope is a feat of engineering. At its heart is a 6.5-meter wide mirror made up of 18 hexagonal segments, each coated in a layer of gold. Its size means it can detect the incredibly faint light coming from the most distant stars. It also has a huge sun shield about the size of a tennis court. It's made up of 5 layers, each as thin as a human hair. And this protects the telescope from the heat and light of the sun.
The James Webb was designed with very lofty science goals in mind. To look back in time 13.5 billion years to see the first galaxies that formed in the universe and see how they changed and evolved to get to the type of galaxy where we live in today. Also to look at the first stars, the first light in that universe, stars that were 300 times more massive than our sun, and that when they exploded as supernova generated radiation and heavy elements that made us. James Webb will continue looking for planets around those stars, exoplanets, and will be able to look in the atmosphere of the planets to see if it detects the type of elements that we identify as a sign of the life that we know: water, carbon dioxide, methane. James Webb is also able to look in our neighborhood to look at planets, comets, and asteroids in the solar system.
Orbiting the Earth. James Webb will operate around the Sun-Earth second Lagrangian point. Now that's a point 1 million miles away from the Earth, 4 times farther than the Moon, on the opposite side of the Sun. It follows the Earth around the Sun every 365 days, and it's a point where the gravity of the Earth and the gravity of the Sun combine to make a relatively stable point. The science of James Webb demands a 6-meter class telescope. And with a primary mirror diameter of 6.6 meters, the James Webb will be the largest telescope ever put into space. It'll be over 6 times bigger than its predecessor, the Hubble Space Telescope, and have light collecting power over 44 times greater than a previous infrared telescope, the Spitzer. Now, aside from just the size, science also demands that the telescope be cold, because you don't want the telescope glowing brighter than the faint stars that it's going to look at. And that telescope has to be very cold, about 55 degrees above absolute zero, or minus 360 degrees Fahrenheit, all 3.5 metric tons of it. And the science instruments have to be even colder. They have to be around 40 degrees above absolute zero. To get to those temperatures, we built a sun shield that is essentially an umbrella that'll keep the telescope and the science instruments in the shade.
we're going to be able to observe the very first galaxies and stars. We're talking about 3.5 billion years ago, so it's really mind-blowing if you think about it. And why infrared? Well, those galaxies emitted their visible light many, many millions of years ago, and that light travels towards us in time, and at the same time the universe expands. So in that process of travel and expansion, the light shifted from the visible to the infrared, and so we will be able to actually observe those very original primeval galaxies. And not only those, but it will also allow us to observe everything in between, so we can understand the evolution of our galaxies from the first ones to the ones we see today.
Exoplanets, we want to study their atmospheres, and as a reminder, exoplanets are planets that orbit distant stars, so we're looking for very small signals when we study their atmospheres. And Webb is this giant telescope that we're able to use to collect these small signals and look for infrared signatures, chemical signatures of water and methane and carbon dioxide, those types of molecules in their atmospheres. And why the infrared? You know, that's really because those signatures are the strongest in the infrared. We know that they exist there, and so that's why we want to use Webb to look them. Dust, but how stars and planets form in the first place, they are forming in these very dense clouds of gas and dust that come together, and it's very difficult to see through them with normal visible light. And so the infrared is actually able to see through that, almost like an X-ray, you know, sees your bones, sees through our skin. You can use the telescope like Webb to see through the dust and see the inner stars forming, or see some newly formed planets that are also very warm from having just formed.